Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, BrainFlood, a runtime code generator for brainfuck using .NET Reflection. It's wild.
Wild is right. I saw the benchmarks. A brainfuck interpreter achieving surprisingly good performance, even competing with highly optimized compilers. But the runtime code generation part, that's what really grabbed my attention. How does it even work?
Right, so the author initially built a brainfuck interpreter, benchmarking it against Naoki's optimizing compiler. Then, the real magic happened. They created a compiler that generates code at runtime, completely bypassing system.reflection.emit. It's all done using .NET Reflection within sandbox's sandboxed environment. Amazing!
No system. Reflection.emit? That's a huge constraint. What techniques did they employ to achieve this? I'm guessing some clever use of generics and constant folding?
You're spot on. The core idea is to represent brainfuck bytecode as a chain of C# structs, each representing an operation. These structs use generics extensively, leveraging monomorphization to encourage the JIT compiler to aggressively inline and optimize the generated code. They also cleverly use constant folding to pre-compute constant values within the generated code. Ingenious, right?
Absolutely. But how do they handle constants? Brainfuck doesn't inherently have constants, does it?
That's a great point. They create a hierarchy of structs to represent constants. Simple constants like 0, 1, 2, etc. are represented by dedicated structs. More complex constants are built recursively using other structs, allowing them to represent any integer constant. It's a bit like building numbers using only addition and subtraction, but in a type-safe way. Clever!
So each brainfuck instruction translates to a C# struct? How does the runtime code generation fit into this?
Exactly. The runtime code generation uses sandbox's simplified reflection API to dynamically create these structs at runtime, based on the brainfuck bytecode. It's like building a program out of Legos, but the Legos are generated on the fly. Incredible!
I see. But isn't this approach incredibly inefficient? I mean, generating code at runtime seems like a huge performance bottleneck.
That's a valid concern. The author acknowledges that this isn't the most efficient way to build a compiler. In fact, they explicitly state that using system.reflection.emit would be far simpler and likely more performant. However, the goal here wasn't necessarily optimization, but rather a demonstration of what's possible within the constraints of the sandbox environment. It's more of a proof of concept than a production-ready compiler.
Got it. So it's a fun, impressive hack, more than a practical solution. The benchmarks are still quite surprising, though. What are the next steps for this project?
The author plans to tackle WebAssembly next, which is a significantly more complex challenge. This will require more sophisticated control flow and data flow analysis. It'll be interesting to see if they can pull it off, and how it compares to other WebAssembly compilers. Exciting times ahead!
Definitely. This has been a fascinating discussion. Thanks for breaking down this complex project for us.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We'll catch you next time with more exciting tech news. Goodbye.
Bye-bye.